got two different examples. One's a graph, which they're calling m of x, and one's the equation. These are not the same. All right. P of x is the equation. M of x is the graph. How many roots does each one have? Let's start with the graph one because I think that's a little easier. Anybody remember from last year where on the graph the roots lie? On the x-axis, the x-intercept. So how many times does it cross? 2. There we go. M of x has 2 roots. All right. This graph has 2 roots. Again, I don't need to know what they are. I just want to know how many. And let's go to the equation now. I got 3x to the third plus x squared minus 5x. Guys, keep in mind, I don't need to know what the roots are. So don't try to go and solve this thing. You're just making a bigger headache for yourself. I don't like to say the trick, but it is a trick. Anybody remember just by looking at the expression how you can tell how many roots it's going to have? Yeah. Largest exponent. The largest exponent up here is 3. So this tells me this will have 3 roots. Done. That was it for that one. That's it. So m of x has 2 roots. P of x has 3 roots. So choice 1. Not bad. All right, some of these are going to be nice and easy for you. Some of them are going to be out of control for you. We all good here? We all right? All right, a little bit different for the next one. Number 5. Which expression is equivalent to this one here? All right, first thing, we got to review it. You start pulling this business again, just because they got X's and I'll cross them out. Oh, I see a 6. Let's cross them out and go cross off happy. Get out. All right, that's not what we do around here. You're way better than that. Next thing you might want to try to do is factor the top. And I wouldn't blame you. All right, you're like, yeah, maybe I'll factor the top and I'll cross out something with that X plus 6. All right, you're going to run into a problem because is there a GCF I can take out of the top? Any number in common? Can I take out an X? Nope. Okay. Can I group this sucker? No, because how many terms are there? Odd number of terms I can't group. Only an even number. So you're not factoring it. So you need to one of two things. I'll show you one way here, and we won't do it all out. But you can go X plus 6, whoop, divided by, put all that underneath, and get after it. Probably not want to do that. That's going to take forever. And we're only on question 5. So there's another method, which I mentioned yesterday, and that is to synthetically divide it. So it goes like that. Can you help me, new kid here? How do I synthetically divide? I know it's got a little box. That's about all I know. I don't put 6 in there. I put the opposite, -6 in there. Yep. And the numbers out in front. Anybody got a big boy, big girl math word for those numbers? Nice! Coefficients. So I got 2, 8. Whoops, sorry. I got 8, -25, -6, and sorry, that's going a little lopsided there. One warning, it didn't happen here, but I would not be surprised if they did it to you in 8 weeks. Make sure all the exponents are represented. Let's say I don't have a squared term. Instead of -25 in here, what do you still have to write? 0. All right, you have to have every exponent represented. So if 1 is not there, it's missing. It skips over from 3 to 1. You got to put a 0 between here. All right, all have to be there. All right, nice job. How do I do this now? You got it set up for me, right? How do I do this? Drop the first coefficient down. Whoop, 2. Got it. Then, yep, multiply 2 times -6. I always multiply by that number. That'll give me -12. So that'll give me -4. Keep going with me. Keep multiplying, and I'll get +24. So that'll give me a -1. -1 times -6. 6. That gives me 0. Keep going. I get 0. And what's my last number here? 14. Yep. Whew, so which choice here do I pick? Yikes. First thing, let's go over the last number. And when you synthetically divide, anybody know what that last number is when we are synthetically divided? Remainder. Yeah, that is the remainder. That's not the last number, it's the remainder. How do you write the remainder? 14. So the last thing is going to be plus 14 over whatever you divided by. In this case, x plus 6. And I know that this is an easy choice now, but how do I write the rest of it? Whatever the highest exponent was, this will be one less. So 2x to the third minus 4x squared minus x. There is no number because there's a 0 there, plus your remainder. All right. Good old days, huh? Are we having fun reviewing or what here? We good? Liz, you good over there? All right. Prediction on your Regents exam? Don't be 80? Okay. Questions? What do we got coming up for tomorrow? What can we get excited for tomorrow? Ooh, inverse. Yep, inverse and solving a radical equation. Yeah, I can't wait for that one. Stop. Stop. You're such a drama queen. And then I give it back and she's got like an 86 on this. It was so tough. I failed it. Other questions? All right, put that one away. Back to a little probability. Back to probability. Quiz Thursday. I'll remind you again, quiz Thursday on all this probability that we're doing. Quiz Thursday. Before I go on to today's topic, is there anything you want me to answer from last night's assignments? And again, if you're not trying it, I'm sorry. I don't know what to do for it. It's going to be tough stuff. Anything theoretical versus experimental? Hi, Langston.
Hi. Can you do 2C?
Sure. Yep. Based on the experiment, would you recommend the, okay, so what did you find for the experimental probability, a winner in the second, or all three groups? What did you find your probability to be? 47 over 150, which is about can you go in your calculator real quick? As a percent, what 7? So about 31%, right? And the owner wants a maximum of 33% to win to run the game. So would that fit? Yeah. So that's why he's going to recommend the owners that they do it, because he wants, at most, he wants 33%. You got 31%, so that's good to go. Anything else here? It's going to get slightly tougher today. You ready? Good talk. Okay. Phones away. Let's go. Phones away. Here we go. I don't even know what's wrong with this group. Sure. Blue or blue is going in the box. If For you guys watching this at home, this is going to probably be a bad way to do this, but since you're not visually seeing it. 3 yellows. Two green. How are you? Good. Thank you very much. Appreciate it. And 3 brown going in. Okay. What's the probability Ian picks a yellow out right now? 3 out of 12 chance, 1 out of 4 if we wanted to reduce it, right? Okay, he takes his yellow, back in. What's the probability JT picks a blue right now? Is that probability affected by Ian putting his back in? No, right? So we call those two here, Ian picking the blue, putting it back in, or you were yellow, right? Picking the yellow, putting it back in, and JT picking a blue. Those are independent events because Ian's draw did not have any effect on JT's. Everyone agree? So those are called independent of each other. What's the probability Rachel picks around? 3 out of 12. Watch your mouth now. What's the probability Jason picks a yellow out now? Why 11? So you're telling me because she kept it, that affects his probability. So now, unlike these two gentlemen over here, where they're independent of each other, these two are dependent. All right, because Rachel keeping it affected what Jason picked out. Does everyone see that? Okay, we're good? All right, go ahead back in there. I'll be back. No, I'll be back. Independent, they're two totally separate of each other. One does not affect the other. Dependent, one probability is affected by the first outcome. So I have 3 different, where'd it go? There it is. 3 different scenarios for you. I'm going to roll a die, then spin a spinner. Are those probabilities affected at all by the other? No, not at all. So these two would be considered independent. Okay. 30 without replacing the first one. Would that affect it? Why? Because I'm not putting it back in. Anytime you're not replacing it, it will affect the second probability. So we consider those always dependent of each other if you're not putting the first one back in. What if you take a coin from your pocket, put it back in your pocket, and pick another one? Those are independent because they're not going to affect each other. Are we okay on this concept? Dependent before we actually find the probabilities now. All right. Oh, a bag, kind of like my crayons or colored pencils. We got a bag, 6 black, 9 blue. You can read the rest. We get it. A marble selected, replaced, and then a second marble is selected. Hey, is this independent or dependent? Independent or dependent? I'm hearing 2 here. What do I do with that first marble? I replace it, right? So this would be independent, right? I put it back in. Find the probability of selecting a black marble. All right, go ahead. Black marble. How many are there? 6 black marbles out of 21. And what are you doing to that marble? Putting it back in, and then you want a yellow one out. How many yellows do I have? 4 out of how many marbles are still in the bag? All right. So again, black. This was yellow. Now, what should I be doing with the 2? Anytime, ready guys, anytime you draw or pick twice, 2 or more times. Everyone agreed I picked 2 marbles out of here. Anytime you pick 2 or more times, you multiply all the probabilities involved. All right, anytime you draw, select, pick 2 or more times, you are going to multiply all the probabilities. And thank goodness we have fraction templates. Please don't tell me you cross multiply here. Oh, my heart. You're going to multiply numerator times numerator, denominator times denominator. Or, hey, how about we use that fraction template? Got you to use all year long. Who hasn't? Mike hasn't even known it was there for the last 3 years of his math career. And I'm sure there's more right now that have never used it because they're too scared to ask me because I know I'm going to rip their heads off. Until you use them the wrong way. Yep. And there goes that 100 on the regions. Yep. So we end up with, oh boy, you guys are getting ahead of me. You guys, what you reduced it? I had 20. I didn't reduce. Sorry, I have 24 out of 441. What's that reduced down to? Thank you. And again, I'll take either answer though. That's fine. All right, we good there? Oh, I am going to be challenging you on this next one. Cindy randomly draws 3 cards. Oh, we got to review that deck again. And what is she doing after she takes a card? Ooh, without. So this is dependent. So everyone watch out here. It's going to affect the probabilities. Find the probability she draws a 2 on the first one, a 5 on the second, and not a 5 on the third. Stop. Buckle up. Here we go. A 2 first. Review your deck. How many 2s in the deck? 4 out of 52. So 4 out of 52 for a 2. All right, let's go 5 now. How many 5s are in the deck? 4. Watch your mouth. You already kept the replacement. Why 48? You're only doing 1 card. 1 card each. So it's going to be out of 51. Everyone with me, because this last one's going to be the toughest one. 4 2s, 4 5s. Everyone see why I'm going down? Because I kept that first card. Here we go. Not a 5 on the next third and final draw. Well, first, how many cards are left? Oh, how many cards are left? Now let's think before we just start sputtering out numbers. Out of those 50, how many are not 5s in that deck? I'm getting different ones. I like it. I got a 46. I got a 47. How many 5s are in the deck, guys? 4, right? Didn't I already pick one? Now there's 3. Out of those 50, there's only 3 5s in there. So how many are not 5s? 47. Want me to go through that again? Why it's 47? Because you already picked one, so now there's only 3 5s in there out of the 50, which means 47 of them are not. And what am I doing to all 3 of these? You just drew 4 times, so you're going to multiply them. I didn't reduce this one either. I kept it large. If anybody has the reduced answer, I'll hear it. Wait, 150? Going over one? Oh, okay, because your calculator won't change it back in? Okay, that's fine then. All right, I'll always accept the decimal too. That's fine. Just make sure that decimal's between 0 and 1. Yep, that's fine. All right, so your calculator didn't change it back into a fraction. That's fine. I'll just leave it like this then. All right. How are we doing? All right. All right, a little word problem. Hey, Jane, going to take a flight. Albany to Chicago. 90% chance it's on time. First time we've dealt with a percent. Thanks. On the same day, hey, there's rain in Denver, which is going to be 50%. What's the probability her flight's on time and it also rains in Denver? So both happen at the same time. First question, does one affect the other? If her flight's on time from Albany to Chicago, and no. So these are what type of events? Independent events, all right. Independent. All right, so let's find the probability both happen at the same time. Ready? What's the probability her flight's on time? 90%. And I said this is the first time we've dealt with percent. How do I write that as a fraction? 90 over 100, yeah. And what's the probability it rains in Denver? 50 over 100. And since I'm doing two different events, what do I do with these probabilities? Multiply them, yep. A 9 out of 20 chance, 45% chance that both happen. Can I challenge you a little bit? Dom, settle down. What if I change it to? What if I change this question to? What's the probability her flight is not on time, and it rains in Denver? How would you adjust what we wrote up there? 10 over 100, good, times 50 over 100, good. God, you guys are good, good. Oh, toy bin, here we go. Contains 12 toys, 8 stuffed animals, and 3 board games. All right. Now that's not somebody mistook. Mistake was mistook. Is that even a word? Good talk. There's 12 toys plus 8 stuffed animals plus 3 board games. Okay, there's not just 12 total in there because 8 plus 3 doesn't equal 12. There's 12 toys, 8 stuffed animals, 3 board games in there. Marsha chose 2 items. She's willing items for the child. Ooh, that's cute. She's babysitting. I would never have anybody named Marsha babysit my kids. I don't know that. Sorry if anybody knows Marsha. Sorry. What's the probability she picks 2 stuffed animals? And she put the first one back or no? No, she did not replace the first one. All right, so ready? 2 stuffed animals. First pick. How many stuffed animals are there? 8 out of how many toys? Or total objects in the toy bin? 23. Now, please watch your mouth. She did not replace that stuffed animal. What's your probability of getting a second stuffed animal? Why 7? Because you kept that one. So there's not 8, there's 7. And how many objects in the toy bin? 22. And since you picked twice, what are you doing to the probabilities? There you go. You guys are good. Good. And we're looking at 28 out of 253. All right, are we okay on this independent, dependent? When to change the probabilities, -1. We're okay because I'm going to go a little different direction now. Now we're going to go back to picking just once now. All right. Mutually exclusive. Before I get into this, I wanted to show you what I'm talking about here. How many people take science in here? Any science right now? Okay. Gotta take that. How about in English? I wanted something where I'm trying to figure out something where not everybody takes. Can't say math either because obviously. So I got science and language. How many people take a language in here? How many people take both? Science and language. Okay, good, 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 good. How many people take science? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many take language? 1, 2, 3, 4. And how many take both? Okay, perfect. I'll be right back to that example. All right. There's a reason why I think it's easier to have you guys actually hear and show you why. All right, so here you go. I got a standard die. I'm going to roll it once. What's the probability I get a 3 or a 5? 2 out of? Everyone, we're okay with that? 2 out of 6? Where'd that 2 out of 6 come from? Why is there a 2 on top? Why is there a 2 on top? What's the probability you roll a 3? And then what's the probability you get a 5? 1 out of 6, right? How did I go from 1 out of 6, 1 out of 6 to 2 out of 6? What did I do to them? I didn't multiply this time. I added them together. All right, and that's what we're going to start doing when I pick ones. The probability of less than 3 or a 6. Less than 3 or a 6. Well, ready? Less than 3. How many options do you have? So 2 options out of 6, right? And then how many 6s are on there? 1 out of 6. So how many total do you have? 3 options out of the 6. All right, so now I'm adding them. These events right here, a 3 or a 5, are called mutually exclusive. Pretend you have a die in your hand and you're going to roll it. Is it physically possible to get a 3 or a 5 at the same, a 3 and a 5 at the same time? It is? What kind of die you rolling? It is not possible. All right? That's why we say they're mutually exclusive, because they cannot happen at the same time. Can you get a number less than 3? and a 6 on the die at the same time? No. That's why we say they are mutually exclusive. They cannot happen at the same time. Everybody good? Okay, let me go back to my example back here. How many kids total do I have here? 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I don't know, did I count those right? All right, you ready? I want to find the probability that I pick that somebody takes science or language. I want to find the probability that I pick somebody in this class that takes science or language. A lot of people are going to say 14 out of 15, but there's a problem. Watch, ready? How many people, raise your hand again if you take science? So I'd count all you guys. Keep your hands raised. How many of you take language? I have a problem. Some of you guys, I'm counting you twice, aren't I? Can I count them twice? No. No, I got to do what? I got to subtract out the people who take both. Everyone see that? I can't just add them up and say 14 out of 15 because, for example, I'm counting her twice. I can't do that. So I need to subtract her out at least once. Do we see that? Yes? Okay, because that's what we're going to get into right now is when they have something in common, something that's not mutually exclusive, that they're separate. So look at my card example I have down there. Let's finish this off strong. What's the probability out of a deck of cards you pick a 2 or a diamond? Out of a deck of cards, a 2 or a diamond. Ready, everybody? A 2. How many 2s in the deck? 4 out of 52. What's the probability you picked a diamond? 13 out of 52. Hate to break it to you, you counted a card twice. What card did I count twice in both cases? The 2 of diamonds. I counted the 2 of diamonds here because it was a 2, and I counted the 2 of diamonds here because it was a diamond. So I need to subtract out that one repetition. Just like some of you guys were repetitions in science and language. I couldn't count you twice. I needed to subtract the once at one time out. So when there is something in common, I need to subtract it out. So now it wouldn't be 17 out of 52, it'll be 16 out of 52. Yep. Are we okay with this concept? Why I need to subtract out? Because you're counting people twice or cards twice. All right, and well, insurance company. Go ahead, read through the old insurance company. Oh, a little probability quiz here. All right, what's the probability they have at least one policy? So they can have one or both, right? That's at least one. They can have one or both, right? What's the first type of policy? Car insurance? Okay, what's the chances they have car insurance? 56, which we know is 56 out of 100. Other type is home insurance. How many have home insurance? 48. But I can't just add those up. Even if you want to just add those up, what's the problem? It's going to be over 100. And there's people who do both, right? So what do I have to do with the 18% that have both? Subtract them out. Yep. Because again, you're counting people twice. So the probability will actually be, calm down over here, 86 out of 100. If you want to reduce, go ahead. And then what's the probability they have neither? So they don't have either policy. How can I use A to my advantage here? They have neither policy. If 86 out of 100 have both, or excuse me, have at least one, the rest of them have none, right? You either have 1, 2, or 0, right? This is at least one means you have either one or both of them. So what's left over? You have none, neither. How can I find that probability if I know 86 out of 100 have at least one? Yep, I can take 100 out of 100 if you want to write it as a fraction minus the people who have at least one or two. And that'll tell me how many have none. About 14% of them have none. 14 out of 100. Either by yourself or in your group, try out number 11 on your own. And I'll walk around seeing how you're doing, and then I'll tell you which one to go to next. Kind of like our science and language question. Yes, got it. Yep. Now do number 11 on the homework for me. Good. Good. Now do number 11 on the homework. If you get 60 out of 100, you're good. Go to number 11 on the homework. Okay, you're adding up everybody, right?
Yeah.
But some of these take both, right? How many take both?
Oh.
8, right?
Yeah.
So you're actually counting 8 people twice. You see why?
Yeah, I see why.
All right, because the 8 would be included here and here. You only want to count them once, so you want to do what with that 8?
You want to subtract
Subtract off the 8 out of 100, right? Okay, go ahead and if you get 60 out of 100, go to number 11 on the assignment. And I'll walk around to see how you're doing on that one. Figure out if you're replacing it or not. Figure out if you're replacing it.